let's do example number 4. You were supposed to finish this sheet, right? Yeah, I think you were. I can look on yesterday's video, but I'm pretty sure. Okay, do I have growth or decay on this one? Growth or decay? Why? Because my B is less than 1. Good. If you really want to make your algebra teacher happy. Was that Nick that answered that? Wow. That's impressive. If you really want to make your Algebra 2 teacher really happy, you could say it's a fraction between 0 and 1. But I will accept B is less than 1. Okay, y-intercept. We're not going to worry about the y-intercept, right? We're going to... Huh? I gave it to you a couple days ago, didn't I? Okay, so we're not worried about the y-intercept. We're more worried about, yes, a lot of students in here, asymptotes, right? Asymptote. Okay, so to find the asymptote, we need to graph it, right? See where it's almost touching the line. Okay, with these, in fact, with the section before this, with analyzing graphs and this section, you're always going to need your graphing calculators, right? So you might as well get a graphing calculator. Okay, so I'm going to put in 1/2 raised to the x, graph it, and sure enough, it's decay because it's declining. I'm going to get some points. Let's see, -416 I don't need. I need -3. Wonderful. -2 is -1, 0, 1, 2, 1, 2, 5, that's an eighth. And 3, I'm sorry, yeah, this is 0.25, this is 0.125. That's a quarter, that's an eighth. Okay, so where's my asymptote going to be? Just by looking at the graph. It's a line, it's a horizontal line, could be vertical. In this case, it's the horizontal line where my graph is approaching but never crosses. Yeah, y equals 0, right? No. And I'm going to show you that in about 5 minutes. No. I know what you mean. I used to know this. Stalactite and stalagmites, right? Stalactites, I think, are from the top. Mites are from the bottom. Good. Isotopes are... Now, boy, you are really trying my memory. Isotopes are... Is it sound waves? Isotopes? I don't know. So I have y equals 0. No, and I'm going to show you that in about 5 minutes. Okay. Negative 3, 8. Negative 3, 8. And please draw an accurate graph. If you draw what I showed you yesterday, I'm not going to give you credit. Negative 1, 2, 0, 1. And then we start going towards that x-axis, or y equals 0. Oops. Okay. Yeah, but don't make it cross the x-axis, okay? And try to, like, follow it. Okay, domain. What's always my domain for exponential growth and decay? Yep. Your range is what's going to... Shh. Hey. Hey. Give me the phone. I promised your mother. Give me the phone. No, I don't want to catch it. Then I'll be responsible for breaking it. Okay, range. Again, the range is our y values. So what number does it approach? Now be careful. What number does it approach? We said it. 0, right? It approaches 0. Now, does it go to positive infinity or negative infinity? Positive, so it's going to be over here. Now, end behavior. What are you going to do when you see end behavior? The words end behavior. It should automatically click something in your heads. Yes, you should write down the template, right? F of x approaches blank as x approaches blank, right? That's the template. F of x approaches blank as x approaches blank. And you're supposed to fill in the blanks, right? Well, what's the easier blanks? Yeah, negative infinity here and positive infinity here, right? As x goes to the left, as x goes to the right, okay? As x, well, let's go ahead and do this. As x goes to the left, so I'm looking at my x-axis, right? What happens to my y? Here's my y values, right? What's happening to my y values? As I go to the left, yeah, they're increasing, right? Goes to infinity. Be careful. Okay, let's be careful now. We're starting at our origin, right? As x goes to the right, where is my y going? 0, right? Because it doesn't go past 0. And that's it. The range is what's different. Well, be careful, because on the previous problem, we had growth. See, the previous problem, we had growth. See how it switched? My 0's going to the left, and infinity's to the right. Here, infinity's to the left, 0's to the right. Okay? All right, so you asked me, does the asymptote ever change? Not Dakota. Caleb, what are you doing? Guys, put the phones down while I'm talking. How are you going to learn? Okay, but it's not your attention. You have no idea how many conversations I have about cell phones every single day. It's just in general, Caleb, in general. You can't be learning in every class if you have your head on the cell phone. You just can't. Okay? All right, so let's look at a different asymptote. And don't have one. Yes, I do. Okay, so let's go to number 9. Let's look at number 9. Now, I told you before that in Algebra 1, you use the equation y equals a times b to the x, right? Well, we're in Algebra 2 now. We're going to use the real equation, which is y equals a times b to the x minus h plus k. Look familiar? It should. We've been using it all year long, right? Just in different forms. It just so happens that our h and k are 0 in this formula. Okay? In Algebra 1, if you don't put your phone away, I'm going to throw it in the garbage. It just so happens in Algebra 1, you used 0, 0 for h and k. Now we're going to have different numbers in Algebra 2. For instance, look at number 9. Okay, I have y equals 3 times 2 raised to the x minus 1 minus 4. Now, in all of our different forms, vertex form, we had all kinds of circles, HK we dealt with, right? When we're dealing with h, what happens to the graphs that we had? Which way did it shift? In other words, if I had absolute values around the h or squared around the h, which way did this shift? Left or right? Yeah, it shifts left or right. What about the sign? What does the sign tell us? So which way is this going to shift? Right. It's always opposite the sign, right? H was always opposite the sign. So this is going to go right 1. There's one shift. The other shift, the minus 4, which way is that going to shift? If it's outside the mathematical symbols, up or down, right? Yeah. So it's going to go down 4, right? Okay, so there's my shifts. We can put it here. Let's see. Right 1, down 4. Okay? So, what do you think are... Oh, I'm sorry. It goes here. Sorry, my fault. Okay, so my shifts are right 1, down 4. If I'm shifting the graph left or right, okay, remember our parent function was 0, 1. We always had that point. So if I'm shifting this to the right 1, so now we're going to have 1, 1. So my 1 goes here, correct? Okay. Is that going to, let me ask you this. I did it on purpose. That you could just put parent function in there. You don't have to cross it out. Now, if I shift this whole graph to the right, is that going to change my asymptote? Okay, so looking at our last problem. If I shift this entire graph to the right one, in other words, it'll look like this, right? Does it change my asymptote? No. So what's going to change my asymptote? The down 4. Okay? This is going to change the asymptote. So where's my asymptote going to be? Down 4. So instead of y equals 0, it's going to be y equals -4. There's my new asymptote, right? Makes sense. What's my domain? We could do this even without graphing the graph. Yeah, negative infinity, positive infinity, right? We know that it's growth, right? We know that it's growth. All this stuff without even graphing it. We know that it's growth because b is greater than 1. What's my range? If it's growth, what's my range? Well, yeah, but be careful. The asymptote changed. -4, right? And it's going up, right? Positive infinity. You could almost do the end behavior without graphing it. If you're really good at this, right? End behavior, f of x goes to blank as x goes to the left. F of x goes to blank as x goes to the right. Well, I'm just saying, we can actually, you're picturing this in your head, right? You're that good at mathematics, you can picture this in your head. No? Well, if you have to, we can graph it. So I shifted it to the right one. I'm going to have to go down 4. So I know that it's decay, right? I know it's going to do this, get to that -4, and I know that it's going to grow really quickly. So it should look something like this. Right? All this, I just used logic in my head. Didn't even use my calculator yet. Proud of me? You guys should be able to do the same thing. Okay, let's do this. Let's see, I've got 3 times 2. Now, when you have exponents with more than just x, you have to use parentheses, right? Raised to the parenthesis x minus 1, okay, minus 4. Graph it. Oh, it's growth. I did it wrong. My fault, big shot. Oh, look at that. What a perfect parabola. What? The whole thing is what? Switched, yeah. Not yet. I don't know how you guys do it. I just don't know how you guys do it. What? Okay, so as my x moves to the left, what's happening to my y? Where does it approach? As my x moves to the left, what happens to me y's? Yeah, it approaches 4, right? Negative 4. Oh, it does not. You're just saying that. As my x goes to the right, what's happening to my y? Hey! Hey! Off the phones. Okay, want to do some shifts real quick? Let's do number 12. Shift. How do I get from here to here? What are my shifts? Left 1 and down 2. What's my domain? Negative infinity, positive infinity, right? My range. Careful of my range. Not 2. Negative 2, right? See how easy that is? You guys should get an A on this section of the quiz on Friday, right? Do you think you guys can do the rest of the problems?